Hello and welcome to another Flightgear simulation. As you might have heard in the news, about 1 week ago there was an engine breakdown on a flight from Denver International Airport to Honolulu on a United Airlines flight, United Airlines 328. And today we want to simulate what this whole situation looks like from a pilot's perspective. So I already activated the multiplayer mode in Flightgear, and here you can see our plane standing on runway 25 on Denver International Airport. And we will follow the regular approach pattern, so turning to the northwest. And here in this area, on the outskirts of Broomfield, to be exact, in this area here where you can see that hand, this is where some debris of the broken engine number 2, so the right wing engine, fell down on the ground, landed in some gardens, but fortunately no one was hurt. So let's jump into the pilot's seat. And there are two things I would like you to notice. First of all, the airport of Denver is already on an altitude of 5,300 feet. So keep that in mind when we are returning to Denver, that we have got enough ground clearance for the approach. So it's not on sea level, but way above. So it's on the edge of the Rocky Mountains in 5,300 feet. The second thing we need to prepare for, to simulate the breakdown of the right wing engine, we have to operate the two thrust levers of our Boeing 777 independently. And how do you do that? When we have a look in the help menu, there you can find in the description, you can select certain engines, 1, 2, 3, 4. In our case, there's only 1 and 2, by pressing the exclamation mark, @ hash or $. So first of all I will press the @ sign, and then I'm able to operate only the right thrust lever, and then I switch to the left thrust lever, pressing the exclamation mark on my keyboard. And to operate both at the same time again, it's this select all engines, you have to type tilde on your keyboard. So tilde, and now we're back to regular operation. Just a quick look from the outside. So this is what it looks like. We're standing on runway 25 on Denver International Airport, and here you can see the modeling of this spectacular airport terminal. So let's turn the view. And we are already ready for takeoff. Flaps 15. Release the parking brake. Add 40% of thrust to start rolling. And once the engines have stabilized, we use full toga thrust. Check again if really both thrust levers are operated. Okay. Keep the plane on the center line with your rudder pedals. So we rotate, retract the gear, and go to flaps position 2, 5 degrees. We will be following the runway until the end of the runway, and then we turn right for our first checkpoint called Mukbe in 10,000 feet altitude. So we're at the end of the runway. Bank to the right. Flaps position 1. Want to accelerate to 220 knots. Remember the speed limit below 10,000 feet, 250 knots. Okay, leveling the wings to be heading straight for first checkpoint Mukbe. And now that we've reached our target speed, flaps up. Okay, we can also activate the autopilot. Go to lateral navigation to make the plane follow the pre-selected course heading for Mukbe, and also flight level change to 10,000. Make sure that we don't sink. So plane is now leveling, but it should climb again. Okay, everything fine. We're a little bit too fast, but autopilot and auto throttle will take care of that. In a minute we will be down to 220 knots. And let's have a look at the map again. So we're now heading away from Denver towards the vicinity of Broomfield. So once we've reached our first flight level of 10,000, there are a few things that we have to do. We have to speed up the plane to 300 knots. We have to climb to 12,000 feet for the next checkpoint Ralphie, and we have to change the altimeter from airport air pressure to standard. So now we're at 10,000. Returning for next checkpoint Ralphie. Adjust 12,000, and don't forget the flight level change. I tend to forget that. Also switch off the landing lights and switch your altimeter to standard. Okay, plane is speeding up. And after 4 minutes of flight time, this engine breakdown on the right engine occurred, and we will simulate that by retracting the right thrust lever to idle and cutting off the fuel line with this switch of the right engine number 2. And this all happens when we're 8 nautical miles out from next checkpoint Ralphie, so we're already close to it. Here you can see our position, and here this is the area where those debris from the engine went down. So we're almost there. Okay, now 8 miles out, and now we make this happen. First, I press ET on the keyboard. No, first I deactivate the auto throttle for the right engine, and this deactivates the auto throttle altogether. So we're now on manual throttle mode. Then cut off the fuel line and select the left thrust lever with the exclamation mark. And now we're in manual thrust mode, so we try to keep the speed, and we have to turn left immediately because we're heading for the Rocky Mountains range. So we go to to heading hold, and we turn left to 120 degrees to be roughly heading on a back course to our departure airport, Denver International. So we would be waiting for instructions from the airport controller to tell us what to do, which runway we're allowed to use for the emergency landing maneuver. But as this is just a simulation, there's no ATC on duty, so we have to just do the maneuvering all by ourselves. Okay, 2 more things to do. So we lost the right engine. Power is 0%. Okay. We will trim the rudder a little bit to the left to counteract this asymmetrical thrust situation that we get. So our plane has a tendency to yaw to the right because we only have the left engine, and so we counteract this by trimming the rudder 2 to 3 degrees to the left. Also, we will change the squawk from a regular 4000 squawk to 7700. Okay, that is done. Then we will slow down the plane so that we're allowed to sink to 9,000 feet. We are now too fast for that. I dialed in into the radio stack, into the navigation radio. I dialed in the frequency of the VOR of the VOR DME of Denver. So we're 25 miles out. And we can also see it here on the map instrument that we're heading back to Denver. But in the real situation, the pilot opted not to return to Denver on the same and to touch down on the same runway like as he took off on runway 25 or runway 7. Because he was buying a little more time to run through some emergency checklists, for example, to extinguish the fire that had broken out on the right engine. So here you got several options for the fire extinguisher with this switch here. When you press it down, and you can turn it to the right and turn it to the left to release different stages of fire extinguishing activities on your right engine. So that's what they did, but here in this Flightgear model, this switch is not animated, so nothing to be done here. So we will try to follow the same flight path as the pilots in the real world situation did. So we're heading back to Denver, but not straight in, but we will be passing Denver Airport on its southern side in a 90 degrees angle, meaning heading straight to the east. Then once we're 25 miles out from Denver Airport, we will turn left heading north, and then we will try to intercept the ILS of runway 26 instead of 25, which was our departure runway. Our touchdown runway will be this one, runway 26, and we will try to intercept the ILS. So I tried this maneuver a couple of times before I did this recording for the YouTube video, and my main takeaway was, when you have a single engine failure, you're not supposed to do the landing maneuver with full flaps, so you use significantly less flaps. So now we will descend to 9,000 feet. 9,000 flight level change. Flight level change does not work now. I'm not sure if this is modeled correctly, but you can. There's a tweak how you can do the flight level change anyway. So you use the vertical speed. You use a decent vertical speed, like 700-800 feet per minute. We are slow enough for the speed limit below 10,000 feet. And of course, as we are sinking, we are gaining speed, so we have to retract the thrust lever just a little bit, not to speed up too much. We don't want to be faster than 250 knots. 240 would do. Okay, we zoom out a little more. No, let's zoom in. And once we're south of Denver Airport, we will turn from 120 degrees to 90 degrees, so straight heading to the east. Okay, let's have a look at the map again. So we have just been passing the city center of Denver, and this may be one of the reasons why we cannot dump any fuel. Under normal circumstances, it would be advised, as the tanks are completely full for the flight to Honolulu, to dump fuel. But as we are now over the city center of Denver, I would not dump the fuel now. Also, we don't have enough time to lose enough fuel for the touchdown, so we will just not jettison any fuel. We will try to do this heavy load touchdown anyway and see how that goes. So now that we are south of, so we're a little bit too fast, let's retract the thrust lever a little more. And now we will turn to our eastern course from 120 to 90 degrees. Always make sure that your speed is okay, especially that you're not too slow, because it will be very difficult to recover from a stall with a heavily loaded airplane and only one engine. So I tried this landing maneuver with full flaps and it failed several times. So this is the main takeaway. Don't use full flaps, because once you're too slow, once you get into a stall, it will be extremely difficult to recover from that stall with only one engine. You better stay away from the stall speed. So don't use full flaps. Try to minimize the drag on short final. Okay, we're still a little bit too fast, but as we're in an emergency situation, I think the ATC will not punish us for that. Still have to be sinking down to 9,000, but remember, it's not 9,000 feet above the ground, but it's just less than 4,000 feet above the ground. You can also see the ground is quite near here. Also have a look from outside. Here you can see the rudder trim. So the rudder has turned a little bit to the left according to our rudder trim operation to counteract the thrust from the left engine. And we should be able to see that the right engine is out of commission. The fan blades are not turning, whereas on the left side the fan blades are turning. So this is modeled correctly in Flightgear. Let's keep the flight level of 9,000. And let's keep a decent speed of around 220, between 220 and 230. I will dial this into the auto throttle, but I do not activate the auto throttle. It's just for orientation. And in case the auto throttle kicks in for any reason, there shouldn't be any unreasonable numbers in here. So that's why I also completely deactivated the auto throttle for the right engine, so that the auto throttle does not kick in at any time and distract us from our actions that we have to take for the touchdown. Next thing, we have to correct the air pressure from the altimeter. So we return from standard to the air pressure that we selected when we were standing on the runway, 30.22 inches. This causes a little jump here in the altitude measuring, and so the plane tries to readjust again to 9,000 feet. That's okay. 230 knots is also okay. And we have to look at the DME reading here. Once we are 25 miles out, let's have a look at this. Normally, we would start intercepting the ILS once we're 20 miles out, but as this is not in a straight line, but in a, let's say, 40 degrees angle, we have to add a little safety margin. So once we are 25 miles out from the DME of Denver Airport, we will turn left to turn base for our approach. Okay, we're getting too slow. Let's add more thrust. Let's say 70%. Now we are way too slow. We are already on the edge of a stall warning. So let's speed up the plane. 80% to speed up. Okay, and to speed up the whole process, there will be not much going on until we're 25 miles out. We just tweak time compression here. Go to 4 times time compression, and you can see the plane is rocking a little bit. So that's because of this uneven thrust of only the left engine and the counteraction of the rudder trim. Okay, 230, it's okay. Speed. And now we're almost 25 miles out. Okay, 24, that's good enough. So we turn left. 360 degrees, heading base, straight to the north. Now I switch the navigation radio frequency from the vordme to the ILS of runway 26. So I just switch these two frequencies. The runway orientation is 263. There should still be a DME signal, but now it comes from the ILS radio instead of from the VORDME. Here it is. It kicks in from time to time. It's not as stable as the VOR, but you get some distance information. So I will use flaps 1, only 1 degree, to slow down a little bit more to, let's say, 210. But we will keep the flight level. Okay, instead of using the map instrument, we will now use the ILS instrument. And once we are close to the ILS signal, we will turn from 360 to 330 degrees to have a more pleasant angle to intercept the ILS beam. Let's have a look to the left, but we are too far away to see the airport. 20 miles out is too much. You can expect to see the airport when you're below 10 nautical miles. At least 6 miles out you should be able to see the runway. Okay, let's have another look at the map. So as you can see, we have turned base, we're heading north, and we're aiming to intercept the ILS of runway 26. Okay, 213 knots is okay. Okay, so let's have another look. We're getting closer. Time to turn left a little more. 330 degrees. And let's go for flaps 5. Around 190, 200 knots. Let's have a close look at this bar here. Once this starts moving in, we have to press the localizer button here on the autopilot panel to intercept the ILS. Check once more. Now we're getting closer. Add a little thrust. We're getting too slow. Now we're at 70%. So this is the ILS kicking in. So we press the localizer button. We will be overshooting the ILS signal slightly, but it doesn't matter. We have plenty of range to correct that, so the autopilot will get this job done. We will now approach the ILS signal again from the right hand side. Let's not get too slow. Use 80% of thrust to speed up a little more. And also let's start the sinking. That will also give us some extra speed. Flight level change still doesn't work, so we use a standard sink rate of 700 feet per minute. And that should give us significant acceleration, so that should give us sufficient acceleration again to stay away from the stall zone. This is paramount. Don't get into a stall, because you might not be able to recover from that. And once we have aligned with the ILS, we can go to flaps 15, which will also be our final flaps setting, so the touchdown speed will be significantly higher than normal. We can now prepare for the touchdown, so we use auto brakes 2 and arm the speed brakes to press the airplane down on the runway. Okay, we're getting too fast. Now we use flaps 15 and we will keep this setting for the time being. We can add more flaps once we are directly over the runway. Okay, you can see this pink diamond here, so we're perfectly aligned with the runway on a horizontal level, but we still got no vertical ILS reading here. There should also be a diamond here on the vertical scale, but there's nothing to be seen yet, so we're just doing a standard sink rate of 700 feet per minute. This equals roughly a 3 degrees glide slope. Turn on the landing lights. Let's run through the final checklist. So just wait a little bit more until we got the runway clearly in sight, and then we run through the touchdown checklist. One final look at the map. So here it doesn't seem like we're so well aligned, but from the pilot's perspective it looks quite good. Yeah, we're a little bit left. We're a little bit right of the runway. You can see this in this angle here also on the ILS instrument. So this is something we have to correct manually once we turned off the autopilot for the touchdown. Okay, 168, that's good. Don't get too slow. This is very important. Make sure that you don't touch down before the runway. That would be fatal. Here you can see now the vertical ILS indicator is kicking in, so we're too low at the moment. So we will just, yeah, we are holding the current altitude until this diamond here comes down to this middle line. And now we run through the final checklist. So flaps 15, speed brakes are armed, gear down, and landing lights are on. Speed is too low, we will speed up. Okay, deactivate the autopilot and speed up a little. We use full thrust now on the left engine to get away from the stall warning. We want to get a little faster. So this is a very shallow glide path that we're using, but I think we will be doing fine now. So once you hear the stall warning you have to take immediate action. Use more thrust on your remaining engine, and also pitch down a little to gain speed. Don't let the plane get too slow. You might not be able to recover from that. To be react very swiftly. Okay, 160. We can still slow the plane down in the last minute by applying more flaps once we are very close to the runway. Now 165 is a safe speed. So we turn a little bit more to the left to get a better runway alignment. Now it looks much nicer. 165 still.
Approaching 26.
Okay, more flaps, because we're now a little bit too fast, and even more flaps. You can now use full flaps.
Too low terrain. Minimums, glide slope. Too low terrain. Sink rate 100. Sink rate 50. 30. 10.
Okay, we will not use thrust reversers as we have got only one of them, and I don't want asymmetrical braking from this one remaining engine, so we just leave the job to the auto brakes. And like in the real world situation, we will come to a standstill on the runway and wait for the fire brigade to extinguish the right engine and also to be towed away from the runway. So I will now also shut down the second engine. Okay, so here you can see it. This is our final situation on runway 26 of Denver International Airport. This was for sure not as smoothly as the real pilots handled this situation, but at least we got the job done. So this is more or less what it feels like to fly this maneuver with a single engine failure 4 minutes after departure. So as always, thanks for watching and see you again next time. Goodbye.